All right, welcome to the first video in the FSL tutorial series. So this is the first quality assurance or QA step that you'll be applying, and I'm assuming you've already converted your data from the NIfTI format, from DICOM to NIfTI format. There will be a link in the info box to a Tumblr post I posted, and in that Tumblr post is a line of code that could possibly work for you. Of course, you have to install whatever you need to install for that line of code to work. You can Google it and find it. But anyway, I think that line will work for a lot of you to convert your DICOM to NIfTI. If it doesn't, actually I would start by asking around your lab to see what people typically use, because it can change from lab to lab, and even as settings on the scanner change, you might have to do something different. So what do you do now that you have NIfTI files? Oh, right. And for the rest of you, if this is your first time ever analyzing any fMRI data, I highly recommend, if you have the time, just using some open fMRI data instead of your actual data. For one, if you screw up, if you delete a file or something, you can just retrieve the files again and start from scratch. Also, any weirdness in the data I will discover before you and let you know, and I doubt there's any weirdness because the data have been analyzed before. So you'll just be tackling your own mistakes and not mistakes that are kind of out of your control with the data, which is good. Once you get the steps down in the analysis, you will be more well equipped and you'll have better ideas for troubleshooting other issues in your analysis. So I'm using the DS008 data. Again, go to the Tumblr post. I have a whole section on where to get these data, and also I have a Python script linked into that Tumblr post about moving some of the files. So Russ has already created some of the files, and I would like to create them all from scratch and not rely on his files. There's absolutely nothing wrong with his files. It's just I want to be able to go through all the pre-processing steps with you. So you can go find that Tumblr and the Python script and run it, and it's just simply moving some files for you. So go ahead and do that. And these are the basic steps that I could think of for the first QA step. If there are other things you typically do after you've converted your DICOMs to NIfTI, leave a comment. Leave it in the Facebook group or on the Tumblr or on Twitter. If I miss something, tell me about it. And at the end, as I said, at the end, I'm going to put together a single document with all the steps and links to all the scripts. If I have to edit any of the scripts based on your comments, I will, so that at the end you have this nice little package of how to analyze your data, complete with scripts. And most of the scripts will be in Python. Okay, so the first step is to make sure all your files exist. This is an example of the type of command I use in Linux to look for all my files. So here I'm looking for the onset files, which I'll show you in a second. They're stored in a subject file. Here, let me just show you one. Right. So if I look in subject 001's directory, they have a bold directory, an anatomy directory, and a behavioral directory, and a model directory. If I go into model, there's model 001. So let's go into model 001, and there are onset files. Okay, so for this data set, there are 2 tasks, and each task has 3 regressors that need to go into the model. And I didn't read the README yet. You should. I'm assuming it's a stop signal task, so it's probably go trials and then the correct and incorrect stop trials or something like that. We'll get there later. When we model the data, we'll know for sure. 3 runs. There's going to be more than these. There we go. There's 4 conditions to model. And we'll look those over later. So the first thing I want to do is make sure all of these text files exist for everybody. And while we're here, because I'm going to talk about these onset files later, these are all in the 3-column format. So to look into a file, you use the more command. So more will just spit out what's in a text file. So what this is the 3-column onset. The first column is the time in seconds, the second column is the duration of the trial, and the third column is the parametric modulation. If you don't know what parametric modulation is, go to the Tumblr post I linked to in the info box and actually link to a whole video on parametric modulation. An example would be if this were a gambling task and there was a certain amount a person could win on each trial, you could modulate each trial by that amount. Likewise for loss. So, if you're using these pre-prepared data, we are assuming these onset files are correct. Oops. Okay, so to check that everybody's exists, here is that command I just showed you. So this, if I just do the ls portion without piping it into more, I'll delete this for a second. It spits it all out, which is fine. You can then scroll through it. But if you pipe it into more, it only shows you one screen at a time. So this is just a single screen, and you'll have to read it very carefully. And one way to do it is to make sure it goes 1, 2, 3, 4, 1, 2, 3, 4, and then quickly check that it's, subject 1, and then it's just going through the different runs. 1, 2, 3, 4, 1, 2, 3, 4, 5. So that's interesting. We're going to have to learn why there are conditions 5 and 6 for certain runs and not for others. So anyway, we'll get there. I'm just looking over the files for now. When I'm done with this page, I hit the space bar and it gives me the next page. So I can check this over again. And some have 6 again. It's probably just a task difference. So anyway, read the README file and make sure you understand what all of these files are and make sure everybody has everyone that they need. I'm going to assume they're there for now. If they're not, we'll worry about that when we get to actually modeling the data. You can edit this and check other things. So if I want to check the actual bold data, we can do that by editing this to do task 001, 09 underscore run 0009 star. Great, and now it's going to show me all the bold data. So I just need to make sure everybody has a file. So this is only going to show a file if it exists. So it's up to you to pick up when one doesn't exist. So for example, right here, subject 2, task 2 only has 2 runs. So I'll need to make sure later that task 2 is only supposed to have 2 runs. It looks like some do have 3 runs. So that's interesting, and that will give us a little challenge when we analyze our data later, that all the subjects don't have the same number of runs. No worries, can fix it later. Okay, we'll ignore these. There's a lot of extra files. I don't care about these QA directories. So that's step 1. Check and make sure all of your files exist. This is just one trick you can use. Step 2 is to make sure your functionals have the proper number of time points. So I have seen cases where the DICOM to NIfTI conversion dropped time points. And then you have to wonder what else went wrong in the conversion. So the easiest way to do that is using the Fsl Nvols command. It's so if I go to subject 1's directory, Fsl Nvols bold 182 volumes. That's great, but I don't want to sit here typing this out for each run to check the number of volumes. So I have written you a script. I will put a link to this. That's not the script. I'll put a link to checkvolumes.py in the info box as well. So this will be in the Dropbox for Mumford Brain Stats. So if you've never used Python before, don't worry, you can totally do it. I'm pretty new to it. I force myself to use it whenever I can. Well, here, I'll exit this session here. To exit, you type exit, open, close parentheses. So to open, I like to use IPython. So Python doesn't have ends at the ends of loops. It completely relies upon indentation. So IPython's a little friendlier about pasting code into it. If you're, say you're editing a for loop, if you copy and paste lines with spaces in front of them, Python will get angry, you can use the cpaste function in IPython to do it. I'm not going to get into that. So I'm going to import glob and OS. Path, I'm just setting the path. You will obviously change this to the path on your computer to the DS008 directory. So I'm going to run that. So if I type path, there it is. Glob is awesome. It basically fills in your wildcard values for you. So, pretty sweet. Each of these is now a path to the file. So now all I have to do is loop through all these files and run fsl envols. So that's why I imported OS. I'm going to use the os.system function to do that. So I can then run this loop and it spits it all out to screen. So then you can slowly scroll through here and check. So this is good for us to know. It looks like the runs either have 182 volumes or 176 volumes. I might want to check into this more later. I'm hoping within task, the number of volumes is always the same. We'll see why when we actually analyze the data. But that's good to know. So go through this, scroll through it, and make sure the number of volumes are what you expect it to be. And again, if we read the README file that was supplied with these data, that will tell us. And again, this checkvolumes.py, this is there for you. All you need to do is edit this. Now, you can either copy and paste the code into Python, or the other way to run it, I think I have a window with it, is the first thing you'll do is you need to make it an executable. So you'll do chmod plus x and then the script. Once a file has been made executable, if you edit it, you don't need to rerun this. Then once it's executable, the more doesn't work well here, you can just run it from the command line doing a period slash and then the name of the script. And then it will run it here to the screen, and you can scroll through and look at it and make sure everything looks good. Okay, so that is the trick for running the Python script. Other things you can do, Fsl Info and Fsl HD are ways of looking at the header of your NIfTI. So I can use Fsl Info, and this just gives me a quick glance. So it does give the number of time points as well as the pixel dimensions and other things. Fsl HD gives the full header. So this has a lot more information in it, just so you know. So far, the only FSL commands we've used are Fsl Info, Fsl HD, Fsl envols. I don't think I've used Fsl View yet, but that's coming up next. So the next step is to make sure your orientation looks okay. So this is when you're going to open each and every image, each structural, each bold data set, and you're going to look at it. I highly recommend this. I realize it's going to take some time to open up all of those all those functionals, but it's the only way you're going to find some of these errors. So let me do one of a proper brain. That one's messed up. Oh, here, we'll just do this one. This functional data, so it's going to be less resolution. Okay, so the first thing you want to check, and this isn't showing up for this image, and that's fine. We should be seeing labels. Let me give you a different data set. No, of course, the one time I forget the ampersand. Okay. Oops, I've already run some. You won't have these files. I've already run a little bit of the brain extraction stuff. That'll be next time. Okay, so on your anatomical, you should be able to load it up, and it should have some labels here. So the superior, inferior, anterior, posterior, left, and right. So make sure those are correct. Hopefully you've taped a vitamin E capsule or something so that you can doubly verify which is right and which is left and make sure it matches. Right-left swaps are the worst, and they're the thing that you need to be constantly looking out for. If you apply any sort of command that changes orientation, when you do that, you have to be 100% sure, you have to be 110% sure that you did not have a right-left swap. So most of the FSL commands, I'm going to show you two, are a little robust to that. But there are ways to actually rewrite the header information. And if you have to do that, I mean, I can't stress enough how much you have to double, triple, and quadruple check what you're doing to make sure there wasn't an issue. There was a case with the scanner at one of the institutions I used to be at where for some reason, for some subjects, the left, this weird thing happened and we did have to do that. But it turned out it was something that wasn't being set correctly at the scanner itself. So once we identified that, we were able to make sure that when we acquired the data, we could completely avoid this problem because you don't want to deal with it. It's okay the face is missing, it's supposed to be missing, but otherwise make sure these labels are correct and that the head is oriented just like this in the viewer. The face is facing to the right here, it's facing forward here, and left is on the right and right is on the left in this view. In this other image, I think this one, nope, that's later. Here, this is an example where the orientation's messed up, but the labels are correct. I'm 95% sure that if these labels are correct, your future analyses will run fine. But personally, I just like the orientation to be correct before I start because then I know things are 100% fine. So how do you fix that? Well, you can use the command fsl reorient to std, which I'm not actually going to run it today because in the next step when we do the brain extraction, I'm going to have a script for you that actually loops through all of the structurals. The Python script I showed you here is actually looping through the functionals. But next time we're going to be looping through the structurals, so if you need to reorient, we can do it then. Those of you using the OpenFMRI data, you won't have to run this. It's already been run. Or it's the data don't need it. So that will be included in the next script. There's one other command, I didn't write it down here, but there's another command called fsl swapped in that allows you to swap the dimensions. So if the fsl reorient to std doesn't do it on its own, you can use fsl swapped in. I like fsl swapped in because it typically, as far as I could tell when I've used it, is robust to accidentally doing a right-left swap. Has a little catch in there and it will print out an error message saying it refused to do something because it was afraid it would cause a right-left swap. Yep. So that's that. Last, have you prepared your onset files and are they okay? So I already went over that structure and this command up here actually checked that they all existed. And 3-column format, typically what you want to use. First column again is onset time in seconds. Second column is the duration of the stimulus, and the third column is the modulation value. If you have modulation, if you don't, you will put ones there. So that's it. That's all I got for the first one, but that'll keep you busy. Simply opening all those in FSL view and checking them will keep you busy. And I know you might be tempted to not do it, but it's always good to look at your data and make sure it looks great, especially if you're in the process of acquiring your data. You want to fix any issues at the scanner. You want to fix them now. If your structurals are in bad shape and you're not getting good image registration, which we'll get to in a few weeks, you want to catch it now so you can fix it. So thanks a lot. Please join the Facebook group, follow on Tumblr, follow on Twitter, or all three. And again, if there's a quality assurance step that you run at this point that I didn't go over, let me know in one of these places, and then we'll add it to this thing at the very, very end. I'll kind of do like a revamped series of steps with everything in it. And so we all have that at our fingertips. So next up will be brain extraction, our skull stripping. And I will see you then. Have a great day.